If placed where the Sun is, it would extend to the orbit of Jupiter. It is huge, truly unstable, and on the verge of a cosmic explosion. With the potential to release the energy equivalent of 1 billion suns, this explosion would be one of the largest radio bursts in the universe. Are you ready for what's to come? One of Earth's closest neighbors, the massive red supergiant Betelgeuse, recently caught the world's attention by experiencing a noticeable dimming event. This outage has raised questions and conflicting emotions among the public and cosmologists. Many people wonder, what does this behavior mean? According to some scientists, this unexpected behavior could be a sign of an impending cosmic explosion, a catastrophic event that occurs when a star runs out of atomic fuel and collapses under its own weight, causing a massive explosion. The public is also concerned, wondering if such an event could affect Earth. Betelgeuse, also known as Alpha Orionis, is easy to spot in the night sky due to its unique shape and brightness. Recent data from NASA's Hubble Space Telescope and other observatories indicate that a massive mass ejection will occur in 2019, garnering the interest of astronomers around the world. Coronal mass ejections are common on the Sun, but this massive event from Betelgeuse offers new insights into the behavior and life cycle of large stars. Astronomers still debate the exact distance between Betelgeuse and Earth, with estimates ranging as high as 724 light-years. Red supergiants like Betelgeuse are difficult to measure accurately due to their enormous size and unique properties. With a luminosity thousands of times greater than that of the Sun, Betelgeuse is one of the brightest stars in the night sky. This intense luminosity accelerates the star's demise by burning its atomic fuel at an accelerated rate. Despite its incredible brightness, Betelgeuse's demise is inevitable. Betelgeuse will eventually run out of fuel and collapse under its own gravity, creating a supernova that could produce a black hole or neutron star. Would such an explosion pose a threat to Earth? Current astrophysical models suggest that even if the explosion were to occur hundreds of light-years away, the consequences could be significant. Supernova explosions can sometimes emit so much light that it's equivalent to an entire galaxy, meaning that a Betelgeuse explosion could have far-reaching consequences. Since the last known supernova in our own galaxy in 1604, humans have not witnessed a single localized explosion. However, in 1987, a significant supernova occurred in the Large Magellanic Cloud, 169,000 light-years away. Although Earth was not directly affected, this event reminded us of the immense power and potential impact of cosmic phenomena. The concept of a danger zone for supernovae is compelling. If a supernova were to occur closer to Earth, it could have devastating consequences for life. However, supernovae are minor events compared to gamma-ray bursts, which are much more powerful and pose a different kind of threat. Gamma-ray bursts can destroy the biosphere and blanket planets with deadly radiation. Certain types of cosmic explosions can destroy a planet's ozone layer, exposing it to deadly cosmic radiation. Recent research has confirmed this unique risk associated with the dramatic death of a massive star. When a massive star explodes as a supernova, it becomes the brightest star in the universe. A single supernova can be brighter than millions of stars combined. This raises an interesting question. What would happen if Betelgeuse became a supernova? Betelgeuse will be the second brightest object in the sky after the Sun. During its explosion, Betelgeuse will shine brighter than the full moon and can be seen even during the day. Even in complete darkness, its shadow casts a majestic display of cosmic power. However, the visible light from a supernova, as amazing as it is only a small fraction of the energy released. High-energy radiation, especially in the form of gamma rays and X-rays, is the real problem. This radiation could thin the Earth's ozone layer, which protects us from harmful solar radiation, exposing the Earth to intense ultraviolet radiation that could cause mass extinctions. In the long term, cosmic rays and subatomic particles from supernovas will penetrate the solar system, increasing the risk of the initial explosion. These cosmic rays could potentially damage the ozone layer and flood the Earth with dangerous radiation for centuries. Evidence of previous supernova impacts on Earth has been found in ocean sediments and lunar soil containing high levels of iron-60, a radioactive isotope produced by supernovas. This suggests that Earth may have been affected by a supernova eruption relatively recently, perhaps within the past few million years. Astronomers have concluded that none of the supernova candidates near Earth are close enough to pose an immediate threat. But new research has identified a special type of gamma-ray burst that could be deadly over long distances. As stars age, they form a huge disk of material. The shock wave from the explosion rapidly heats this disk, producing high-energy X-rays that can travel across vast areas of space. This intense radiation could severely deplete the planet's ozone layer, creating conditions that could lead to mass extinction within 150 light-years. Fortunately, no such supernova candidates have been found in the immediate vicinity of Earth. A new study of the habitable zone of the galaxy, the region most favorable for life, also yields interesting results. Some regions of the galaxy are poorly populated with stars, allowing rocky planets to form, while the inner regions, where stars form and die quickly, are prone to supernovas that probe the surrounding space. The study suggests that the habitable zone may be farther from the galactic center than previously thought. So what happens to Earth when Betelgeuse goes supernova? The Earth's biosphere will probably not be affected, but the sight will be unforgettable. For about 90 days, Betelgeuse will shine as bright as a crescent moon, appearing as a bright in the sky during the day. The explosion will cast a glowing shadow at night, captivating skywatchers around the world. This cosmic phenomenon will be visible to the naked eye for several months. Even though Betelgeuse's remnants will eventually disappear, scientists continue to study them to better understand the explosive deaths of massive stars. By learning more about these powerful events, we can understand the evolution of galaxies and the elements produced by supernova explosions. In addition to visible light, the intense heat and pressure of these explosions produce heavy elements such as uranium, silver, and gold, enriching the interstellar medium with the materials needed for future stars and planets. Supernova remnants can also serve as stellar nurseries, where new stars form from the gas and dust released by the explosion. This cosmic cycle shows how the death of one star can trigger the birth of another, and illustrates the interconnected nature of the universe. Astronomers use supernovae, especially type Ia supernovae, as standard candles to measure distances in the universe, greatly improving our understanding of the expansion of the universe and dark energy, the mysterious force that drives its accelerating expansion. Studying supernovae can also provide insight into the conditions necessary for life on exoplanets. Researchers are studying how radiation from nearby cosmic explosions can affect atmospheres and the potential for life, emphasizing the importance of understanding the life-sustaining environment of the universe as a whole. Human history has long viewed supernovae as more than just scientific events. They have influenced stories, myths, and art. In many cultures, stellar explosions symbolize change, destruction, and rebirth. Advances in technology have changed the way we observe and study these events. Space telescopes like the James Webb and advanced sensors allow astronomers to obtain detailed images and data in real time, opening up new possibilities for studying supernovae. In conclusion, the study of Betelgeuse and its potential supernova raises fundamental questions about cosmic evolution, Earth recycling, and the impact of these events on life and society. Studying massive stars helps us understand the complex and sometimes brutal cycles that govern the universe, and helps us understand our place in this vast and ever-changing universe. Supernovae are the most important events in the cosmic timeline, ending the life of a star and triggering the formation of new celestial bodies. Over time, the debris left behind by these explosions can form nebulae, huge clouds of gas and dust that serve as fertile ground for the birth of stars, and potentially the development of organic molecules necessary for life. The shock waves of supernovae can also trigger star formation in nearby molecular clouds, showing how a single explosive event can trigger the birth of new stars and planetary systems. This interconnectedness highlights the importance of supernovae as research centers and cosmic phenomena that fuel the ongoing life cycle of the universe. Supernovae also play a key role in dispersing heavy elements throughout the universe, enriching the material that will eventually form stars, planets, and the various chemicals necessary for life. This cosmic recycling process highlights the importance of understanding supernovae in the broader context of astronomy and the origins of the materials that make up